Okay, thank you, Audrey. And I will kick off with an introduction on what we are doing in the framework of the Decade of Ocean Science for Sustainable Development in relation to data and information management and sharing, and share some insights on the recently established Decade Coordination Office that aims to coordinate this dimension for the decade, but also for all global actors, scientists, engineers that are trying to draw up a picture of our seas and ocean. And then I think afterwards, my introduction will be relatively short, 25 minutes. And then I know that Conor Delaney will zoom in more on one of the regional core services delivering access to data and data products at European level, that's IMOFnet. So good evening, everyone. It's a great pleasure to be here. So let's start with the beginning and frame the Decade of Ocean Science. Where does it come from? You may recall, and some of you may be very well aware, that in 2016, the UN, the United Nations, adopted 17 Sustainable Development Goals for the Agenda 2030. And SDG 14, which is to conserve and sustainably use the ocean, seas, and marine resources for sustainable development, is all about life underwater. It includes a series of sub-targets on pollution, overfishing, and climate change. But at that time, it was already realized that if you look into the details, it is the most or the least funded of all the SDGs, so the least receiving the least resources and attention in the total package, according to a report by the OECD. Realizing the increasing threats to the oceans and the fact that our knowledge is limited, the UN then tasked UNESCO to develop an ambitious 10-year plan to really lift up and boost our scientific understanding of the ocean, to be able to tackle some of these grand ocean challenges and to develop solutions to sustainably and equitably manage our ocean environment. The plan was approved in 2020 by the UN General Assembly. And this is a graph that visually shows you how small the expenditure is if you compare SDG 14 with the other SDGs. So a lot of catching up to be done on the ocean domain. So let's have a closer look at the decade itself. So the decade plan, implementation plan, was delivered and adopted in 2021 with a vision to work towards the science we need for the ocean we want. And the decade framework revolves really around, that's the core of it, decade-endorsed actions, which fall into 4 categories. You have programs, you have projects, you have contributions and activities. All of them are called decade actions. And all of these are working towards addressing 10 decade challenges, some of which are thematic, dealing with tackling pollution, restoring ecosystems and biodiversity, blue food, building a sustainable ocean economy. Others, the 4 last ones, are more foundational and cross-cutting, supporting the realization of all of the other thematic challenges. What is common to all is that they all are very much in need for open, accessible, interoperable ocean data and information. So having an interoperable data sharing framework that allows people to easily find, easily access, retrieve, manipulate, and most importantly, use data and information is going to be critical if we want to be successful under the decade. So, I mean, I don't think it's a secret to you, access to reliable and fast access to marine data is very important for many different applications, whether it's developing a maritime spatial plan or to make sure that we support sustainable blue economy in a sound way for developing policies to protect vulnerable coastal and ocean areas, but also to understand trends and forecast future changes. So if we look, take a snapshot, look at where we are with the decade. We are now already well over 2 years into the program. We have quite a lot of endorsed activities, and they're really gathering momentum and picking up speed. And that also means that we have to coordinate the digital ecosystem that is underpinning all of these activities much more closely. So under the decade, we're working towards those 10 challenges, and we are collectively channeling our efforts and resources to tackling those. It's really an unprecedented global effort to lift up and transform the way we do science, how we manage and how we deliver knowledge and services as well to address these challenges. And if you look at challenges 7 and 8, which deal with the collection and sharing of ocean observations and data, and number 8 dealing with developing a digital representation of the ocean, which is very much in support of sustainable decision making. They are key challenges because they underpin all of the other challenges. That's also why when the decade implementation plan was developed, it paid quite a lot of attention to data and information management aspects. The data implementation plan recognizes that we need to be able to digitize, access, manage, and most importantly, use ocean-related data, information, and knowledge if we want to be successful for the decade. And that's explicitly mentioned as a priority to be resolved. For that reason, in 2022, a group of experts from various parts of the world came together to develop a decade data and information strategy. And this data information strategy was published in March of this year. It's open for consultation, but also to provide feedback because it will be refined and ever improved. At this moment, there's a group looking at a more detailed roadmap to implement the strategy. And at the core of the strategy, the vision is really to work towards a distributed data and information ecosystem, building on regional and thematic systems that already are in place or being developed, with the need that it has to be actively used or prioritized for decision making to support sustainable ocean management. Now, the strategy comes with 5 important strategic objectives, which deal with different aspects that need to be put in place for such a digital ecosystem to be viable and operational. The first strategic objective deals with the development of an ocean digital ecosystem that encourages the sharing and equitable access of multidisciplinary data and information and knowledge by all. What does that really mean? It's really about developing a system that everybody can use. The decade is all about equity. It's about leaving no one behind. So it's really uplifting that capacity, but also making sure that the interfaces to be able to use data and information systems or to share data and information need to be tailored to the needs of the different groups and the different capacities that exist around the world. Very important. The second strategic objective deals with improving the data and information discovery and usability, and that relates more to making sure that we implement practices and systems that ensure that the data is fair, findable, accessible, interoperable, and reusable. The third strategic objective, dealing with building trust in data and information, which is shared across this marine knowledge value chain, is dealing with aspects such as ensuring clear metadata, providing information about how the data is collected, the quality, the provenance, so to ensure traceability. but also to allow for a system that gives credit to those who have collected the data and are sharing it, and that is visible where it is coming from. The fourth strategic objective deals with prioritization of digital solutions that support decision-making for sustainable ocean management. What does that mean? I mean, another very core important aspect of the decade is the aspect of co-development and co-design. So in order to develop a system that is useful, this system needs to be developed and co-designed in the first instance with those who will be using it, who will be relying upon it, not just by the engineers or the technicians. And that's something very important. Also, if we develop digital twin applications or knowledge-based solution, they need to be developed very clearly with the user together and be user-driven. We have only limited resources, and we need to really work towards investing our efforts where it will be uptaken and will have an impact. The fifth strategic objective is something entirely different. The first objectives deal more with partly the infrastructure, the technical aspects. The fifth strategic objective really deals with the human aspect, because at the end of the day, it is still people that will need to develop the systems and people that will need to use it. So it's also about creating an awareness, changing the culture by default data sharing. And I think in some communities, there's still a lot of work to make sure that people are sharing their data openly and that it's available for reuse. The huge cost in this marine knowledge value chain is really in data collection. Going out at sea, observing the ocean is extremely costly. So you have to make sure that it's all, the resources are unlocked and made available for resource. And it's a lot of, let's say, awareness raising that still needs to be done to make that happen. And then there are a number of enablers, technological innovations, partnerships, resourcing, of course, but also policy and regulatory frameworks that need to be adapted. If you look at how much data is being collected by the private sector when they are applying for an offshore license for a wind farm, an aquaculture farm, if those data are not being made available for reuse, it's a huge loss. But for that, we need a policy and regulatory framework that allows for it. So let's have a look at this digital ecosystem that is what we are working towards within the decade. At the end, what we want is end-user applications. We want solutions to solve the decade challenges and the specific problems we are facing. And that's really the very visible part of the whole chain, the ecosystem, and one on which return on investment is often placed. But that's really just the tip of the iceberg. It's often of no value if not fully supported by the underlying, less visible parts of this digital ecosystem that are fundamental. It's the plumbing system, if you like. It's not always very sexy, but it's the hardware that makes the solution reliable and usable. And that requires resources, and that's something that is sometimes forgotten. So the decade really presents an opportunity to lift up all of these components of the digital ecosystem, in particular the ones that are below the surface. Solutions, they involve delivering knowledge and information to decision makers at the right time. But for those solutions to work, we need the necessary infrastructure behind them to support the data and information collection, management, sharing, and use. The four key components of this digital ecosystem that we have in mind, in fact, every kind of knowledge value chain delivering a service has a little mini digital ecosystem. Along these components are the observation, data collection. There's a component of data management and sharing, analytics, processing, modeling, prediction, ultimately the end-user application. So with every endorsed Ocean Decade program or project, you will have such a sort of own mini digital ecosystem. And if we don't coordinate this well, we will end up with many, many icebergs flowing around in this place that are not really connected. and we create more silos, and that's actually the opposite of what we would like to develop. So we want a focused and coordinated approach, and that's also why in the decade we've created a number of coordinating offices, one for ocean observing, which is hosted by the Goose project office. We have the Ocean Data Sharing Coordination office, which I'm leading since June of this year, which is hosted by IODE, that's the International Oceanographic Data and Information Exchange Program of IOC UNESCO. There is the Ocean Prediction Decade Collaborative Center, which is hosted by Mercator Ocean in France. We don't have a coordination office for end user applications because, in fact, the different programs deal with those aspects. You have one program under the decade which is called DITO, which deals with digital twins of the ocean, which is one of the partners that we are working with to make sure that this flow of data and information reaches the end user application as well. Okay, so what will these coordination officers do? They will support the links and information flow in the decade, make sure that nobody is duplicating effort, and that we can repurpose the efforts that are being done in one, or the expertise that is being developed in one by the other. Enable cross-disciplinary co-design, provide strategic advice. Very important also to scan what data is available, but also what gaps exist in trying to solve some of the core priority problems. And then, if needed, provide advice for filling these gaps in infrastructure developments. Very important, as I mentioned, raising awareness, the importance of ocean observation and data literacy, and communicate our successes. So specifically, what will the Coordination Office for Ocean Data Sharing do? We are responsible for coordinating and interconnecting the data sharing component of the decade, which means that we will communicate with the other components to try and agree on standards where useful, bring together the key experts from the different communities to make sure that these components are not disconnected. Very important for this coordination office that we are here really to help those who are working in the programs and projects. So they're really picking up speed, they're collecting data, they're looking for data and information, but we find by the various conversations and surveys that we had with them that it's still very difficult for them to know what data resources exist, what kind of tools and services they can use, and they don't always have the know-how, the capability to share their data and information in a proper way. So we match the expertise in data management that exists with those who need it, offering a sort of help desk, if you like. We are going to do trainings in data literacy and capacity building. And we'll also work with the main data services to try and see if we can increase our efforts to observe certain aspects where there are data gaps and where there are infrastructure needs. One of the main, let's say, expected outcomes of this is to support the implementation of the data and information strategy with a particular goal to address challenge 8 of the decade. It's one of these foundational challenges, to create a digital representation of the ocean. And that includes developing a dynamic map of the ocean and providing tools and services that allows people to easily find data and information on the past, current, and future state of the ocean. How will this work? The Ocean Decade involves a decentralized coordination structure, if you like, consisting of these coordination offices collaborative centers which coordinate endorsed programs and projects. So we, with the DCO on data sharing, we are closely linked with the program Ocean Data 2030, the World Ocean Database, and GeoTraces, which is a more specific program on micronutrients. And so we are each supporting these key programs and projects, but we also coordinate between us. We are also, and that's a part of the decentralized organization structure, liaising with a number of thematic coordination centers, and you have a number of them. Now, I have to say they are not all matching the challenges, but many are. For example, you have the Ocean Climate Nexus Collaborative Center. You have one on marine pollution that has not been established for that matter. There is an active one, a very active one on coastal resilience, which is led by Professor Pinardi in Italy, and one on fisheries and blue food. Then these again will work very closely with the regional collaborative centers that are being set up across the world. And it was a pleasure to be in China a couple of weeks ago, where we saw the launch of the Ocean Climate Nexus. And they are also actively collaborating with some of these regional nodes. So what is on our plate for the DCO on data sharing for the first year? We have to manage expectations a little bit, because we started in June with 2 persons with a total of 1 FTE. So we are starting up the activities. We are doing what we can, but one of our main focus is really to try and establish the DCO, be relevant and useful, but also to mobilize resources for the continuation, not only of the DCO itself, but some of the core programs. Because despite the importance of having the data information component sorted, this is the least funded activity within the Decade universe. There are no resources beyond 2024 for any of the core developments in this sphere. So that's quite alarming. And that's also why one of my core priorities is to walk around the different regions to try and convince potential funders to invest in this very important activity. I'm not going to go too much into detail in all the different tasks and activities, but maybe say a little bit more about the Vision 2030 process, because this is very important. We are now a couple of years into the decade, and a lot of activity is being, and a lot of momentum is being gathered, but we are not always looking into the same direction. So we need to have clear targets, a clear vision for where we want to be in 2030. So under the Vision 2030 process, it's really the ambition setting process of the decade, is to look at, for each challenge, where do we want to be? What does success look like in 2030? Let's be ambitious, but also realistic. Let's try to define what are the minimum viable outputs in 2030 that we can be satisfied with for each and every challenge. And we are dealing with challenge 8, so we're trying to define with a group of experts in the course of this year, what are the main outputs of systems that we want to have operational by 2030. And this will be put in a white paper, 4 or 5 page white paper, so quite focused, which will be presented at the UN Ocean Decade Conference in Barcelona next year in April. I think there are many opportunities for you, for the community, to consult on the progress of these white papers and to provide your input, feedback, and steering. And that's really a very much of a community-driven effort. But it's going to be very important because that will help us to set milestones to really work towards those targets. And how it is developing for Challenge 8 is that we are going to expect that each of the thematic challenges identifies a number of data layers, iconic flagship data layers that they can provide for their challenge, whether it's pollution, for example. What can they deliver to us as part of this digital representation of the ocean? We want to put in place a service for professionals, which is a data and information system where you can easily discover, retrieve, visualize, manipulate data from various disciplines. So from biology, chemistry, physics, whatever, all the way to human activities, data and information that we want to compile and make easily accessible and retrievable. And there's a particular service that we have in mind. We also are going to put forward the idea of developing a global atlas of the seas and oceans, which contains consensus data layers and maps from various providers. For example, one of the core layers will be the Seabed 2030 map, so a seafloor map, the bathymetry, digital bathymetry of the entire seas and oceans. So these are some of the elements that we are trying to agree on as key targets to deliver by 2030. So at the end of the decade, what we would like to have as a lasting legacy is to really lift up the way we manage and share data and information across the decade, but beyond that as well, and plug these into the normative structure so that they become the norm. We try to work towards this cultural change across the different disciplines and have in place a federated ocean digital ecosystem where all the scientists are able to easily find and access data, which will be easier for decision makers to make informed choices and really support the environmental protection and management and enable a sustainable blue economy. Before closing, to conclude, I just want to point to a couple of important developments that will help us realize this vision that are already ongoing or planned. So this data and information service that I was talking about, there is already a concept for that and there's already a plan for it. There's just no resources yet. So it's the Ocean Data and Information System, which is one of the big programs, component programs of IODE. It's been partly developed over the last 3 years by a project that was funded by the Flanders government, which is the Ocean Info Hub, which really worked towards improving the discovery and interoperability of existing systems and linking, let's say, a network of regional and thematic nodes, of which EMODNet is one. So I'm very happy that Conor Delaney will speak after me to give you a bit more insight in how such a regional data service works. Very important is that we provide capacity building to make sure that everybody is able to contribute to such a system and also to use it. Otherwise, it's a bit pointless. So you can already consult it. So I would really invite all of you to have a look at the Ocean Info Hub pages and also at ODISCAT, which is a catalog of sources, which provide already quite a lot of information from various regions across the world. And here you have a snapshot of the Ocean Info Hub portal where you see there is information on experts, on documents, training, data sets, vessels, projects, institutes, and so on. So it's quite interesting. And maybe interesting to know as well that for this first phase, there was a focus on 3 pilot regions: Africa, Latin America, and the Caribbean, and the Pacific Small Island Development States. And voila, the project is running until mid I think April next year. And so we are very much lobbying to get a sort of follow-on project, because this is really how we can make these services operational in practice. Okay, and so maybe just to conclude, we are looking at these digital ecosystems, but we are really, operating towards a digital biosphere. We have just one part of it is the ocean ecosystem, but it's really operating in a big digital biosphere where you have different aspects from healthy oceans to terrestrial atmosphere, cities, and so on. Voila, thank you. On that note, I would like to thank you and pass on maybe to Connor, or if you have any burning questions, I'm happy to take one or two.
Okay. You want to share? Stop sharing there, numbers?
I can. Here you go.
See if I do this correctly. I had a disaster with this last week. So are you seeing my screen?
Yes, we do.
Okay. Hello, everybody, and thank you for turning up today. I'm Dr. Conor Delaney, Technical Coordinator of eModNet, and I am going to give you an overview of eModNet, a bit about the European landscape in context, and hopefully by the end of this lecture, you'll be able to also go and use the eModNet portal to download data. And the eModNet here as well, related back to Jan Bart's presentation there, eModNet fits in a lot into this global context as well, because one of the things that I hope you'll get to understand about at the end of this is how Europe works. We're not one big super government. We're made up of all these member states, and all the member states do their own research programs, collect their own data. But then when it comes to creating European scale data sets, the question is, whose job is that? And in this situation, the European Commission has stepped in to and created eModNet to create the European scale data sets out of all the efforts and work that the member states do. So there's a bit of a parallel there. So I'll go on to the into a brief history. The problem we were addressed in Europe was, as I mentioned, how we have all this data that's been collected, but it was being collected on a national scale. So I'm from Ireland. So in Ireland we have research programs, and we have seabed survey programs, and we were publishing the data, but only for the Irish context. We don't collect data or process data for countries outside of Ireland, but we make our data available to everybody, especially since it's open data. So the question is, how would you take the data, say, from the UK or Ireland and France, and then bring it all together into a cohesive European scale products? And this is exactly what eModNet does. We are a network of many institutions, and we are broken down into a number of different thematic areas. You can think of them as sort of knowledge assembly groups or data assembly groups with bathymetry, geology, biology, chemistry, physics, seabed habitats, and human activities. And these groups gather data from member states and from industry and from other agencies, and create products for these services at a European scale. So and then all these products, because they're funded by the Commission, are published under an open data license on the eModNet portal. But I'll come back to that, more details of that later. So just to emphasize this, we're everything from the seabed to the surface. So from the geology up to what's happening on the surface. And there are hundreds and thousands of data points and hundreds of data providers. And the challenge here as well is that all these different areas like biology, the geology, bathymetry, all these subject matter areas, they all collect data differently. So one of the challenges we have is how to bring all these data together into these products, and how then do we publish them in a way that you have a consistent and stable access to the data products across all of these different areas. And our overriding our mission statement here is collecting data once and use it many times. Also, we're trying to increase productivity and cost effectiveness across Europe for researchers and industry. Some of our data products, for example, the vessel density one here, are very hard, expensive to produce, both in terms of computation and in terms of money. So we actually produce vessel density maps for Europe, and then we give those away for free. We do the processing on a common good for all citizens of Europe. And the people who do the work are all subject matter experts. I know Jan Bart just mentioned Professor Nadia Pinardi, that's her there. And then my colleague Joe here is a biology expert, and Patrick's an expert in modern physics. So they're all subject matter experts in their particular domains, and the eModNet groups then reach out to into their networks and gather data from the National Ocean Data Centers, government agencies, the different and industry. And I will give you a link later on where you can actually go onto the eModNet website and you can find a list of all the data providers, including all the ones from Malta. So we produce key products. When I say key products, if you go down there to human activities, that's a key product from human activities. To produce lots of products, that's the vessel density one. Bathymetry produces the digital terrain model of the seabed for Europe. If it wasn't for eModNet, there wouldn't be a unified digital terrain model for Europe. Physics goes and collects all the different sensor data sets from many different agencies to create one single data set of sensors at sea for eModNet. And seabed habitats takes all data products together and produces the habitat map for Europe. I'll just give you an idea of this here. So the result of all of us working together is that the seabed habitats can take data from physics and biology and bathymetry and do some intensive computer modeling and produce a predictive map of seabed habitats for Europe. And this is another one of our key products, which of course it's also open for anyone to use and download. So how does it work? And I know this lecture is supposed to be on data standards, but I'm not going to go into the detailed data standards of each of the thematic areas. One of the core things, of course, as a scientist, you learn about scientific units and the different standards in science. So there's the practices that are carried out in the particular areas that people are involved in. But the thematic groups then have to deal with how they harmonize within the different across countries within Europe to get the data from the different groups working in those areas. And I'll give you an example of this. In the early days of bathymetry, one of the tasks bathymetry had was to harmonize the data based on what each member state was using as their reference points, their height above sea level. And remember, the different member states were using different ones. So in order to produce a harmonized digital terrain model of the seabed, that had to be figured out. So but the point here as well, you're dealing with subject matter experts, so these are well familiar with how to address these problems. eModNet is a service of DG Mari. It's a permanent service of DG Mari. We're hosted on the DG Mari website. It is filling a crucial gap. If DG Mari wasn't doing this, there wouldn't be anybody doing this, and Europe would not have these European scale products, and that would create a massive problem for us in terms of how we would deal with problems of environment, blue economy, and other insights in the marine of what's happening in the marine space of Europe. But we don't reinvent the wheel. We work with many different entities that already exist in Europe, such as the ICES, which are the entity for looking at fisheries in Europe, the research and other research entities in Europe, the hydrographic offices, the geological survey offices of the different member states. So we don't actually fund any collection of data. We fund the aggregation of data. These are data sets that are already being collected. We're not a data processing service. We don't, when you use the eModNet portal, and I'll come to that later on, I'll show you how to use it. You are using the mapping service on that if you use it for data discovery and download. We don't you can't run geospatial processing on the data. We regard ourselves as being providing a fundamental service for others to build on top of. We do offer a few processed products like the vessel density and the EUC map, but that's because the scale of it is and the scale of work that needs to go into it is really something that you can only do at a governmental level. So what is the added value? So this is emphasizing again the concept that we are gathering all these data products together, or data sets, and producing these data products and then publishing them on a central portal. We follow things called INSPIRE and FAIR data principles. I'm going to explain those now in a moment. And we are multidisciplinary, so we have across many different thematics. And it's a long-term service. It's not like an EU research project that finishes after 4 years. We are here as a permanent service of DG Mari. But we're not the only service for marine data. There is another service for marine data called under the Copernicus program, and that's funded by DG DEFIS. And the Copernicus program is on Earth observation and modeling. So we have Copernicus Marine. They look at the modeling of the oceans and also at looking at the oceans from satellites, particularly Sentinel-2 and Sentinel-3. So they're the two main services for marine data in Europe funded by the Commission. So it's eModNet and Copernicus Marine. So just to film a couple of things on the acronyms and the drivers behind all this. So FAIR, you'll see this a lot. It's findable, accessible, interoperable, reusable data. This is not a law, it's a aspiration. You'll see a lot in research sectors. It's all about being able to find the data, access the data, query the data, and reuse data. And we do our best to be fair. In fact, we are fair in eModNet. INSPIRE, you'll see this a lot, especially in the world of environmental data. It's the infrastructure for spatial data information in the European community. It is a law. It's a European directive on spatial data. It's how member states are to share data that's particularly in the area of environmental assessment. They need to make the data available in a geospatial way so that it can be aggregated and used for assessment or built into other products. And so that's one of the things that we leverage, and we try and make our data as available in that way too. To do that, we use what's called the Open Geospatial Consortium standards for geospatial web services. So because we publish all our data on the web, so we use web mapping services, web feature services, and catalog services for the web. These are all INSPIRE compliant services. And I mentioned this just so that you have an understanding of the type of foundation we use to do what we do. we try and keep in line with what is recommended to the general community, not just our own marine community, but to the inspires the geospatial community and affairs the general scientific community. We also are, one of the other drivers is the Open Data Directive of 2019. This is a reinvigorated Open Data Directive. The Open Data Directive has been a rule of Europe since 2003. Some member states have been doing a better job at making data open than others. The idea being that any data that's funded by the taxpayer should be open. In the new directive in 2019, the Commission recognized what it called high-value data sets. So these are data sets that are geospatial, earth observation, environmental, and meteorological. I have them highlighted here in yellow. And that member states have to make this data available in a way that it can be queried and downloaded very readily and in a timely manner. This is another background driver of what we do. It makes things easier for us. And open data is actually quite an international thing. I mean, America has a massive open data directive. We worked recently with China. They have an open data directive. Many countries have open data directives. And one of the tricks and keys is to try and figure out how you can make that data easier, accessible in an easy way, that you can have interoperability between countries and regions. So just to summarize on this bit, at the very bottom there, you can see the data collectors and data producers, and I put in a link there to the data providers list that exists on eModNet. But if you go to eModNet and look under our partners, you'll see that too. And in that, as I mentioned, you also have the multi-providers that are producing data. Then we have the data aggregators, and a lot of eModNet partners are aggregators, and from those data aggregations are the products that are produced and they're used by anybody who wants to use them, either in science or policy or industry, because they're all published under an Open Data Directive. They're published under, technically they're published under the Creative Commons by 4.0, which is the open data licensing that we use. So just to briefly, I will go over some use cases here so that you can get an idea of the type of things that eModNet products can be used for, and I'll try and reference them straight back to the different thematics. So here we have improving evidence-based management of space at sea and decarbonizing marine transport and offshore energy. So we're directly talking about there is in the human activities area of eModNet. If you go to the eModNet portal, there's a section called to the map here, there's a section called human activities, and in there you'll see the vessel density maps of the sea, but you'll also see things like the areas where the offshore wind farms are, where they're planned to build offshore wind farms, where the marine spatial plans are that ones that have been published. We've also got those. We've also all the aquaculture sites, all the fishery sites, the undersea cables, the undersea both for energy and telecommunications. So just to name but a few, but that's what's been addressed in this particular item. So similarly for providing sustainable food production, so you've got a combination between what the information you'd have in human activities tied in with some of the information that you'd have in biology or in a couple of the other entities like the bathymetry or seabed habitats, where you're trying to look for the best sites to put fish cages and aquaculture at sea. We also have information on climate adaptation, like where the coastlines are and where they're predicted to move to, impacts on disturbances at the seabed, and other things that to think about for the future. And then we have an extensive information on biodiversity. We have a very interesting, in the biology section, one of the key product of biology is the species occurrence for Europe. So you can query by species to find out where those species have occurred, especially in Europe and over time in Europe, in the European seas. Very important. Of course, you can overlay any of this information with the other information from the other thematics. So I'm going to move on now. That to give me this high level view. I'm going to go into more of the technical side, and I'm not going to go into the hardcore technical background and stuff of what eModNet. I'm going to try and give you an idea, a sample of how to use the portal. And if at the end, if desired, I can actually switch the portal on and show you it in operation if anybody's interested. So we have just come from a major redevelopment of eModNet. eModNet used to exist as 7 different portals, but since January of this year, we now exist as one portal on the DG Mari website. This was driven by the Commission. The Commission were very concerned that the valuable products that they were funding through eModNet were not findable, being findable enough, or not easy to find. Let's put it by citizens, and they really wanted people to be directed to one site and not have to go searching for products all over other sites. So we created one website, which I'm going to go to in a few moments, which has one map viewer, one products catalog. But to give you an insight onto what goes on in the creation of products, this is just on the central portal. You can switch on a layer that shows you the sources of all the data from hydrographic data that is used to create the digital terrain model of Europe. So on the left, these are all the different parcels where sampling went on, and these would have been published in that way by the hydrographic offices of member states. And even though it says here it looks like it's Ireland and the UK, these are other member states might have been doing the surveys in those areas. And the bathymetry team will then took all those data and then use some computer processing or modeling to produce the image or the digital terrain model that you see on the right. Now, what's unique here as well is, in the case I have here, of course, we have Ireland in there. Ireland has an open data policy when it comes to its hydrographic data, so it's all open, anybody can take it. But other member states don't have an open data policy with particular areas of their coastline. Some of them see it as sensitive because of security. So, but they make that data available to the bathymetry team, because the bathymetry team produce a DTM at a resolution of 100 meters, which they don't regard as being sensitive in that for them. Now we also have the much higher resolution digital terrain models available for those countries make the high resolution data available. Just to give you a quick oversight there. So with centralization, we replaced the 7 thematic portals with one website. We replaced 7 map viewers with one map viewer, 7 catalogs as one catalog. And we also brought in some new technologies. One here is called AirDAP, but we can touch on that later if you're interested. And we are focusing now on improving consistency across in metadata file formats, downloading APIs and web services. And I'll touch on that as well at the end, because it's very important for the Ocean Decade for international sharing of marine data, and we can show some positive outcomes on that already. So we did in a web technical point of view, web service technical or web design technical point of view, we did a lot of what's called information architecture. We took the data and information that was on we looked at the data and information that was on each of the thematic portals, and we mapped it all to a new information architecture on the central portal, which is now just the eModNet portal. So if you go to the eModNet portal and you look at the themes, you can pick up, say, chemistry or bathymetry or biology, and the pages for those themes are in generally the same layout. Not identical, but generally the same layout. And this is done to help users, to make it more familiar and help them find the things they need to find. We also gathered all the different technical documents that are being published in all the separate portals and brought them all into one place. So if you go in now to the reports section, you can search for technical documents across all the different thematics. And this is, once again, this is very important in order to help people have a quicker access to the documents on how to create products or how to share data. So on the map viewer, I'll just give you this quick overview. That if you've used a map viewer like Google Earth Engine or any other web map viewer, this stuff will be quite familiar to you. You have a layer control on the left, a legend control. We have a section called the subset and download. I'll show you that in a moment. Map settings, and then on the right you have zoom controls like you'd have on any map viewer on your phone, etc. And but as I said, you don't have data processing functionality in this, though we do processing for subsetting the data. So it's just a data discovery and download service. So what you're seeing in the background there is the vessel density layer. And in the next slide, what you're seeing here is the digital terrain model there. Now here, before we centralization, the digital terrain model product existed as 64 separate tiles. If you wanted a unified digital terrain model of Europe, you had to download the 64 separate tiles and then do the processing yourself, which is very technical and very compute intensive. So as part of the centralization process, we did that for everybody. We created one single file. We in the previous slide, I mentioned this technology called AirDAP. We used that technology to host that file, and then we present it to you in the map viewer. So that means if you're zoom into the digital terrain data, here I've switched on the mean depth multicolor, and you hit the download button, you will get a section on the right hand side that you click. This is orange because I've clicked it, but normally it's blue, and then it asks you to draw a picture on the map, or a square on the map, and then you can download the data or the product data for within that square. In this case, it's in the netcdf file format. We do have a limitation of 2 gigabytes, but you can also bypass all this and go straight to our AirDAP server and download the whole thing itself. So we're striving for consistency across the thematics. So for biology, we use exactly the same workflow to allow you to access the biological data on species observations. Now, the biological data on species observations is tiny compared to the DTM. That's a huge file. The complete DTM, if you to download it from our AirDAP server, is 136 gigabytes, whereas the biology data set's quite small, but we felt that it was important that users will have a consistent experience across all these data sets. So in this case, it's similar. I switched on the species occurrence data. I filtered it because we have a filter function. I can show you this at the end on orca whales. So in this case, I zoomed into Norway. If I click on any of these dots, you'll get the number of occurrences of orca whales at that spot, the record count. And then if I hit the download button, I can draw a box around there and I can download the occurrences of orca whales off the coast of Norway. This was not possible before with the old EMODnet. So it's a rapid, a fantastic improvement in services. If you switch on a number of layers, you can download all the data within that box that are for all the layers that exist there. So I could, if I had the DTM on here as well, I would get the DTM data as well. So also, I just wanted to talk briefly about human activities. Human activities, they publish the marine spatial plans for Europe when they're available. They're not all available, but if you go there, you can have a look at the marine spatial plans. But you also have, if you click on the polygons, and you will get links to the metadata. Will show you back to the marine spatial plans of the member states, and you can go right back to the source of where these plans came from. So that's the map viewer. what you see in the map viewer is a subset of all the products that we have available. If you go to the catalog, we have 2,500 products available, but it's all queryable, and all the data, all the products within the catalog are downloadable. But it varies across the thematics of how straightforward a download can be. So if you ever have any problems, just reach out to us and we will help you solve those problems and download those products if you're having difficulties with that. How this all works is because we follow the Inspire directive, we have an extensive metadata catalog that provides information on location. So you're able to query by location, and you're also able to query by category. All the web services that we use are available to anybody else. So if you're building software, or you're using a GIS system, a desktop GIS system, everything that you see that existed on the map viewer is also available to you through the web services, and through everything that's in everything that's in the map viewer comes straight from the product catalog. We don't have any secret sauce here. Everything is open access and available to users. It is a bit technical, but we are in a technical area, so I do apologize about that. So if you go to the portal, we have an extensive description of our web services, but they're also up there on GitHub too. So I did say you can give us feedback. There is feedback on the bottom of the page of the web portal. If you put a question through there, it will go straight into our help desk, and it will start the process where if it's a question about how to use the portal, we can address you directly. If it's a question about the products, or you spot something in the products, a problem with the products, we will contact the subject matter expert who is responsible for that product, and you'll be able to communicate with them directly as well. So just to go on back to what I was saying about fair data and web services and following standards, because we follow standards for our eModNet catalog, we publish under Inspire standards and a number of other catalog standards, means that we can be harvested by other catalogs. So recently, this month, the UN's group on Earth Observation System of Systems portal has harvested the eModNet catalog. So all the products that are in our catalog are also available through there. Because we use web standards on how data is distributed, you can actually access our data directly through the metadata that's in that catalog. Similarly, at the Ocean Info Hub, they are using a much more a slightly different way of creating catalogs. They're using what's called semantic web technologies, but our services also provide APIs for them to harvest that catalog, and they've just successfully done that. And this is part of what I was saying about if you follow these standards or you follow the best practices, and if people all around the world did the same, it'd be very easy for us to create super catalogs of all these data and data services, or for us to share data between regions. So this is what we're doing at a European scale. We're putting forward our technological stack as a best practice to the United Nations Ocean Info Hub, Ocean Best Practices, which is a bit unusual. Normally for ocean best practices, they're looking at ways for people to provide documentation on how the data is collected, or how observations are made, or laboratory techniques. But we decided that it would be a good idea to suggest that the technologies that we use, which are not our technologies, they're all open source technologies, would make a nice use case for others who are interested in improving their data sharing and interoperability. We're not suggesting that you have to use them. We're just putting up there and saying this is a success story, and recommending them. But it's not just at the European scale. We're also looking at technologies that the United States use. We use this technology called ERDAP, and this is produced by NOAA. It's an open source technology as well, and it's got widespread use all around the world. And as a result of that, and it uses standard ways to share metadata and describe metadata. So we follow those ways, and the other countries around the world using it follow those ways too. And because of that, you can then create a super catalog of ERDAP catalogs. This was done as a demonstration by the Irish Marine Institute for no other reason than to prove that it can be done. And they created if you go to erdap.com, you can go there and you can see what happens when countries around the world share their data in a standard way. There is a searchable catalog there that you can go in and find data products and download them and use them. We are also looking ahead. So what I showed you here is very much an idea of data existing in silos, around the world, and data existing in silos in Europe, and all these data being interconnected via web services. And in the EMODnet, we're sort of like a focal point for all these web services. We actually don't host much data in our at our portal, which is hosted in Belgium at the Flanders Marine Institute. The data that you see are hosted at, and the data products that you see are hosted at data centers around Europe. But looking to the digital twins and looking to the current trends and technologies, we realize that there's an expectation, especially with what's been happening with Google and Amazon, where they've been collecting open data and making these available on their services as a side by side with the compute, that if we are to build a better ocean models and to meet the needs for the digital twins, which Europe is looking for to help people make better decisions in the marine domain, that we'd have to bring the data together, the EMODnet in situ observations, which are the observations in the coastal zone, side by side with the Copernicus Marine ocean modeling and satellite observations. So we're doing that. We're working on a thing called a data lake. And the idea here is that so our data in EMODnet is big data. Big data is any data that becomes hard for you to manage on your laptop or your computer. But our big data is small data compared to what Copernicus Marine do. So Copernicus Marine are hundreds and hundreds of terabytes of data. We are tens to hundreds of terabytes of data. What we're doing is creating a data lake where we're putting the EMODnet product data and the Copernicus Marine data side by side in servers in a data center, so that ocean modelers and EMODnet subject matter experts can build faster, better products using these compute services that are going to be made available. But this doesn't replace our existing services. It's just another service that we're offering, and we're working closely with two DGs are working together, DG DEFIS and DG MARE, to provide this as part of our commitment to the ocean decade. It's very exciting, and it's also probably when it's finished next year, will be no one else in the world will have this. Europe will be leading the way with this in the marine domain. So what is a digital twin? Digital twins is this concept where it comes from industry. It's the idea that in industry, they will create digital twins of, say, a production line in a factory, and the managers will experiment with rearranging aspects of the production line in order to see if they can find efficiencies or understand problems. So in the digital twins of the ocean, we're trying to do similar things for things like aquaculture, impacts of litter, impacts of tourism. But to do that, we need to have data and data products that's available in a way that's fast and consistent and scalable and robust. And that's why we're involved in the digital twin, the Ditto project. So when it's finished, you will be able to go in and rapidly create what-if scenarios without worrying too much about the underlying data storage and where you're going to get the data from, and quite straightforward to how to access it. So we also offer another service as well, just to briefly go into this. We also have the Atlas of the Sea. The Atlas of the Sea is where we take, it's an atlas, it's like a traditional atlas. The EMODnet products are used to tell stories or to give better insights onto what's happening in coastal zone of Europe. So we have subject matter experts are turn the data products into these maps. So it's all about mapping. It's an atlas. And our main outreach at the moment is with the teachers and schools around Europe. But the quality of the products are so good, or quality of the maps are so good that they're really usable by anybody. And it's also been translated into 24 of the 24 official languages of Europe. So I'd fully recommend that you also have a look at that. And we've tried our best to make it easier for people to access this by breaking it down into themes. But as you can see, it's quite an awful lot of information in there. But I recommend looking through it. And the Atlas also has an extensive help section with that, including videos on how to use the Atlas and Seas. Now, also one of the things about the eModNet is that we also collect data when possible. So if you're producing data, we have a system called the Data Ingestion Portal, where you can contribute data to eModNet. If you go to the Data Ingestion Portal, you will be connected with the subject matter expert, and they will help you submit data into the eModNet system. So just be aware that if you're doing research or you're doing data observations yourself and you're wondering what to do with your data when you finish working on it. So that's all I have from the slide deck. Thank you for your attention. We do have a conference that's happening in November. Unfortunately, it's not going to be virtual. It's going to be all in live. So unless you're in Brussels and registering it, you'll have to wait till after the conference to see all the videos and the outputs from it. But they will be available on the link that I showed there. You can follow us on eModNet. We have a subscribe to a monthly newsletter. And you can ask questions through that through the link I showed you at the bottom of the page. But also at the top of the page, there is also a feedback section that allows you to fill in feedback and bring it back to the central portal. So I'm going to leave it there. If anybody has any questions, I know I have time left here. So if you want, I can open up the portal and show you a few things and how to do them. If that's of interest to you. I see some things in the chat. Okay. So, Audrey, do you want me to go and show some things around the portal, or anybody in the audience have any questions on the portal? How to use the portal?
It's up to you, really.
Yeah.
Like you said, we still have 15 minutes.
Okay, so I'll just show you a couple of things on downloading data, because it's important that people understand how to download the data, because it's the key thing that we do. So I'll just share my screen. If I can figure out to do this again. Okay. So you should be seeing the data providers list. Are you seeing that? Are you seeing my screen?
Yes, we are.
Yeah. So this is the list I mentioned earlier on of all the data providers. We only put this on 2 weeks ago. It's part of one of the things that we're very concerned about is that we take for granted, or some people take for granted, that some of the tasks that the Commission do in order to fill the gaps that exist, because we are a federated system of countries. We're loosely coupled countries. So we felt it's really important that citizens realize the role their own countries play in producing these products. So we produced a list of all the data providers to the eModNet system. So you'll find the Maltese ones there, and the Irish ones are there as well. So these are, and of course, the background story there is that the member states contribute a huge amount of work to producing these data products, and then because the data tends to be open, we're just harvesting the data from the member states. But we really need to recognize the amazing work that goes on in the background, because this is science and engineering at work. So if you go to the, if I just go straight to the map viewer, and I go to our, switch this off and I zoom out here to the full extent. And I'll just zoom in a bit here and I'll just go straight into it. I'll leave you to explore the map viewer yourself at your own time, but I'll just go straight in. I'll switch on a layer. I switch on the bathymetry layer. I go to the DTM tiles. I'll switch on the depth. I go to the, this one. I zoom straight in. I want to download it, so I hit download. I click in this area of the map. I draw a box. I choose a format. In this case, I'm going to choose NetCDF, which is a standard format in oceanography. And it's done the subsetting and it's downloading to my desktop. It's as straightforward as that. But for the bathymetry, because we also try and deal with the legacy that goes on. To download DTMs before, you had to, in the old system, they had a 64 tiles like this, and you had to click on a tile, and then you were given an option to download the release of the DTM based on a different format. So there's two ways of downloading that there. So similarly, if I go to biology, it's a similar situation. I'm turning on all the occurrence data for Europe, but of course it's a bit of a mess. There's lots of noise there. So what I'll do is I go to the layer, I switch on the filter. I choose waiting for this to load. Okay, well, it's taking a while, so I'll come back to it I'll come back to that later. If I go to, but for them, you would just get the filter, choose your species, and do exactly the same thing you had done for bathymetry. But if I go to other services such as human activities, and human activities is probably our most popular service because it's where all things related to what's happening in the coastal zone are going on. For each of these services, let's say energy, wind farms. There's a little icon here. I don't know if you see it, this I button. If I click on that, that gives you more information. For a lot of our services, our data services, if you click on the icon, there's a download button, and that way you can download the whole data product as a spatial, as a shapefile, which is a spatial data format, which you can open up in a GIS, either Esri GIS or QGIS open source GIS. So I just click on that, it's downloading away in the background. But if I go in also, switch on multiple layers and go in, I can also do the subsetting here. I can select the map and draw it that way. And then you'll see the nuclear power plants data set and the wind farms polygon for that zone, for that area I drew on the map is available. So I just choose the file format and download it there as a CSV. So for all the different thematics, we've tried to make the download service to be, or we have made the download service a variation of one of those two approaches I showed you. You either have to click on the map and draw a box and download, or say in there's also in geology. If I go to geology, you can do the click on the map and download, but it can also download the full shapefile where it's available. We also have access to all the metadata in the background. In this case, geology will take you back to the catalog service of eModNet, and you'll have more metadata than you probably would want to see. So I'll just go back here to the map viewer. We also have a number of tools that allows you to change the projection. So I go out, I have that's just to help you see the Arctic information easier. And then we have a few, you can share a map link, whatever you see on screen, you can share with others. We also have a feature here. If I click out here, sorry, I'll click up here. Oh, into the layers. Catalog, sorry, the catalog. You can add external layers. So in this case, if you go to if you find a web server, a geospatial server that is publishing map layers, and you get their service endpoint and added in here, those layers will all be added into the map viewer. So in the demonstration I was doing on Monday to the Commission, I had taken the Irish Environmental Protection Agency's map server. They make all their maps available through a map server, and I added in there, and then all the Irish maps became available through this service. So you could do the same for any member state that makes, most member states will make that data available through a standard map server, and you can just add it into this map viewer as well. But we're not just about the map viewer. We also have a catalog service. I'll just go to that now. So this is the products catalog, and all the layers that you saw in the map viewer, plus many more, it was 2,217 at the moment, are available to the map viewer, to the catalog, and then you just filter on type. If I go to human activities, and I get the human activities, and then a lot of them you can just download directly from the catalog. So hopefully that's enough for you to be able to go in and use the email service with confidence.
Thank you very much, Connor. I don't know if there are any other questions. Well, any questions?
Yes. No, that's great. Obviously, you all understand it very well.
You are very clear.
So if you go to OBIS, or there's Ocean Info Hub, for example, or GEOS, the same catalog will appear in that. And that's the interoperability that I was referring to earlier on. And the problem we have for global ocean data sharing is that realistically, that's quite a technical challenge for people to deal with. And honestly, I mean, my training is environmental sciences, but I'm also come from a maths computers background. And in the environmental sciences world, this IT technologies can be quite challenging for people. And the trick going forward, I think, is to try and come up with a good compromise between what is technically possible and also economically possible to provide the best service that and provide the data in a way that users can access it without being too technically overburdened, because people just want to do science, or they want to do their engineering. They don't really need to spend a lot of time doing IT support, and that's what we try to achieve. Though I imagine a lot of people would have looked at the presentation and got, wow, it can be a bit daunting.